and welcome back to Power and Performance. Today we are at Morris Lubricants headquarters in Shrewsbury and I'm joined by Dave Jenkins and Alex Sharphouse. Now Dave, I've spotted a couple of bits of your truck here. What exactly is going on?
Oh, well, you might ask. This has been it's the end of our winter development plan, really. There's been some changes with the regulations this year. So we've had to adjust the caster angle and increase some camber angle into the front axle. So these parts are, the big teams in Europe are not releasing the latest technology, and they're very expensive when they do. So we've had a go at doing what we think and calculating where we think we need to be. So last week was up at Alex's, and this is the axle that we've bent now, and hopefully tonight when we get home with it, it'll be under the truck, and then we can do all the wheel alignment on it. And then we're down to Pembury next week for a 3-day test to go and see if it works or not.
So we've got old axle,
yeah,
new axle.
Yeah.
Can you talk us through the differences between the two?
Yeah, so this is a standard axle, comes straight from the scrapyard, cut out of a truck, which is very much where this one originated from as well. So because there's no moving parts, apart from the kingpins, which we replace as part of the process, we don't actually need to start with a brand new item. So we've got two axles removed from old end-of-life trucks, and then we have done the modifications that we need to do to them, and then pressed them back together with new kingpins and new rose joints and new joints, so it makes it new wheel bearings, so it effectively makes it fully reconditioned and brand new then. So this axle here, the main change to what we've done is we've bent the kingpins back in the axle, which is the difference between the flat plane there and that one's vertical. And then when you look at the modified axle here, you can see the flat plane there, and now that angle there. In the past, we were running up to 35 degrees of kingpin inclination, but there's been a change in the rules this year. It's reduced it down to maximum installed angle of 30 degrees of kingpin inclination. And that was because it was putting too much stress on all the steering components, and they were starting to get failures with it. Mm-hmm. So the 30 degrees I'm talking about is the difference between that there, which is flat, which we measure with our digital gauge when we're doing the bending process. So just as it sits in here now, there's 0.2 of a degree on the axle, the way it's sat on the trolley. Yeah, and then when it sits on the top of the kingpin now, there's 26 degrees on that now. Mm-hmm. And then there's another 4 degrees of lean in the spring when it goes in the truck. So all that added together, when it's installed in the truck, that gives us 30 degrees of kingpin inclination. So that was one part of the process, was the actual twist in here of the axle. And later on in the video, you'll see how we actually did that.
It's quite extreme actually, isn't it? You can really see how that's
it's here, yeah. So that process is done hot. So that you can control where the bend occurs, and obviously to make it easier in order to bend. And then
is that a one-man job? Because I know Alex likes to get involved with these kind of things.
It was a many-man job. It took place over 2 separate occasions. The first day there was about 4 of us around it for a day, and got it home, set it all up, and we remeasured it. And as it had cooled down, it had tweaked back a bit. So we went back a few weeks later, and Alex and I had effectively another full day at it. Just making tiny adjustments. Mm-hmm. But the big thing that the rule makers have given us is, because they've taken some of this angle kingpin inclination off us, which is given to us in the first instance in order to improve the performance of the front of the truck, to give it better road holding. That's the point of it. So because they've reduced that angle there, they've actually, which is a more common in car tuning or any kind of motorsport application, they've now allowed us to have up to 3 degrees of negative camber, which is when the top of the wheels are pointing at each other. Mm-hmm. And in the past, you've never been allowed to have any negative camber in the straight ahead position. So the second phase of the bending, once we'd put the twist in the axle then, is to bend the negative camber into the kingpin. Well, it also done at the kingpin, which is another bend here, which we did initially. We did with it hot on a big press, and then afterwards we've adjusted the technique and made a little bit of an adjustment to that. But there's loads and loads of variables when you've got it all set up. You're bending it. You can just watch your fingers, but just as you put the lock on, you can actually see the negative camber changing on the wheel there. So when you're trying to bend it, and measure all at the same time, you've got to keep making sure everything's all completely perpendicular to everything where you're measuring. And when it's all glowing red hot and you're trying to get in there with your little digital gauge and stuff, it was a real tricky process to master.
It's like any of these things, whether it's anything that we do, steam engines, cars, trucks. When you've done one, you're so far up the road than when you haven't, even though you thought about, we thought all sorts of ways of doing this, didn't we? About building jigs, we're going to drop it, we're going to press it, we're going to get our place red hot, put it under 110, press it in one go. When you actually set off to do it, it suddenly all unravels, and that's why the first day really was, we got it kind of somewhere near, didn't we, and thought it was good. But the measuring of it's so difficult, because you put one kink in one way, a tiny bit, it affects the other bit, then you move the other bit and it moves it back, and then even when it cools down, it moves dramatically, because that's a fairly substantial piece of material to get hot. And as soon as you put heat into it, it wants to pull and everything. So when Dave took it home and actually built it up with hubs on, and then he set the tracking up, it's so critical that they're both set together and square. The angles were just ever so off, so that was like last week. It took us a full day just tweaking it. We'd tweak it one way and then tweak the other one another way. But having known what we're doing, you come up with the idea of getting an old set of hubs, and that didn't really matter about it being on when we had it hot. We machined up some steel pins and king pins to put in it, so it didn't matter about it being hot and damaging it. We actually, in the end, did it like more or less
with
looking like that. And we could put a big, we sat this on a big milling machine that weighs 20 odd tons, so it can't move and it's leveled the axle to it, and then we come off these with squares to the bed with the whole thing set up, but still heating it and pulling it and moving it. So it's like it cannot be wrong from what we'd done. There's no way Dave was going to get it home, bolt it all together, and then put it in his truck and start measuring and go, actually, this isn't right.
When we first started with the bare naked axle there, and we'd got it twisted and we thought it was all right, because there's different angles in the hubs and the stubs and everything, when we reassembled it all, it hadn't come out quite to where we calculated it to be. So the second attempt was actually bending it with it all built up, so we can. So the problem is, it takes, to push that kingpin in and out, I should have bought a kingpin really, there's a 50-ton press needed to actually push that component in and out of there. So it's just a massive job.
Don't forget to like, comment and subscribe so you don't miss an episode.